Hey there, everybody. I wanted to take a couple minutes to go over some details about this 7.1 practice problems that you were working on. I did grade and make some comments on those that have been turned in so far, and I just noticed some things that I wanted to clarify that I saw come up a bunch. There is a little bit of wiggle room in the way that you do these, but more importantly, what we really want to talk about are the meanings behind these words: population, parameter, sample, statistic. I want to emphasize that the population and the sample are groups of items. Specifically, we often say groups of people, but as we'll see in problems, they're not always people. But the population is a larger group, and the sample is a smaller group that's taken from that larger group. The parameter and the statistics are specific measurements that are taken about those groups. So the parameter is a measurement about the larger group of the population, and the statistic is a measurement about the smaller group, the sample. Okay, we want to be as specific as possible, and you're not always going to know every single number, but if there is a number available, we do want to list it, and if there's a description of those people or that group, we want to list that too. Okay, so if I'm looking at this example that you had, okay, on Tuesday, the bottles of Arizona iced tea filled in a plant were supposed to contain an average of 20 ounces of iced tea. I'm going to change this just so we can see a little bit better. Okay. That's the population, or all the bottles on Tuesday. Okay, the parameter is the average amount of iced tea in those bottles. Okay, so if I were to take every bottle that was produced on Tuesday, dump it all back into a vat, and divide it by the number of bottles, I'd get 20 ounces. That's a factory setting. Now, we're not going to do that because we want to sell some of those. But if I'm a factory, I might pull out some. I'm going to take 50 of the bottles that I produce, and I'm going to average those to try to see if my conditions are right, if I'm producing things the right way. So I sample those 50 bottles for their average amount of iced tea, and I get 19.6. That's the statistic telling us about the sample. And if you look over here, what that means is, okay, I had this larger group, the population, which is all, bottles produced on Tuesday. Okay, I'm going to assume Arizona iced tea, a big brand, probably produces thousands, maybe even millions of bottles of iced tea a day. I don't know. Okay, but I assume it's a lot more than 50. I can't test every one of those. Okay, but I know that my factory settings, my mu, has to be 20 ounces. Okay, if I average every single bottle. But again, I'm not going to do that. So I'm a quality control person. What I'm going to do is I'm going to take this small group of just 50 bottles. Okay, that's going to be my sample. Now I'm going to run out of space here. And in that sample, my average was 19.6 ounces. That's X bar. Okay. But notice that this specific measurement describes the population, and this specific measurement describes the sample. Okay, so this is my population, this is my parameter, this is my sample, and this is my statistic. Okay, so I want to follow that up with looking at this same diagram here for problem number 1. So in problem number 1, we have a random sample of 1,000 people. Right away, that should tell me that's the small group of people. Okay, it's my 1,000 people. Now, those people all signed a card saying that they intend to quit smoking. Okay, they're asked about it 9 months later. But that sample comes from a larger group of people. Okay, all people who signed a card. And for right this moment, I'm going to ... okay, because I'm just jotting things down. Now, that's not specifically said in the problem, but what we need to see is that when this says a sample, I'm pulling that out of a much larger group. Okay. Now, I'm not told specifically about the parameter here. Okay, I'm not given a specific measurement, but I know that it's going to be a proportion of people who signed the card, okay, who had not smoked in 6 months. Okay, so this is my population, and this is my parameter that is going to describe it. I don't know what that proportion is, and that's really how a lot of research works. It's probably very difficult to follow up with everybody who signed this card. Maybe I don't even know everybody who signed this card. Okay, so I don't know what this value is going to be, but I know how to describe the value. It is a proportion. But what I'm going to do is I'm going to contact these 1,000 people. That's my random sample. And I'm going to find what we've been calling p hat, okay, which in this case is 210 out of 1,000, or, oh, I've got something underneath there, sorry, or 21%. Having a hard time writing there for a second, okay, or 0.21. Okay. Again, we really want to be looking at what's going on in the problem. Okay, draw your diagrams, do that, but let's write that out and note. Okay, I don't want to read too much into this. I don't want to try to project, why they're doing this, anything like that. The population, all the people who signed a card. The parameter, the proportion of those people. Okay. And so I really want to stress this idea that populations and samples are groups of individuals, whether they are people, whether they are bottles of iced tea, and they are groups of individuals. Parameters and statistics, okay, are measurements or values. And I'd say numerical values, but recognize here that we're not always going to know a specific numerical value that describe population and sample. So you're going to see things for statistics and parameters like proportions, means. I think you saw some in there, range, and one of them's a minimum. Okay, these are things that we can measure. They're numerical values that I can find a measurement of that describe the individuals. Okay, so they're not anything else. Okay, we're not reading into that. The other note that I'm going to make, and I did say this about some papers, okay, I do want you to write these out. I know that it's easy to make a list, and not that there's anything inherently wrong with a list, but one of the skills that we want you to be able to work on in this class is written communication of mathematical concepts. So being able to write that out in sentences and complete thoughts is a skill, and it's something that we want you to be able to do. So when I make that note, I'm not saying that a list is wrong necessarily, as long as you have the right information, but we do want to practice that communication in the written form. So we'll work on that. So take a look at this. Just look over what you turned in and see how that matches up. And we'll go from there when we start working on the next part. Thanks.